Physics chapter 19, question number 11. An object moving with SHM goes through 2 complete cycles in 1 second. Calculate the period t, frequency, angular frequency omega. So there are 2 equations that we have to take into consideration here. T equals 1 upon f is 1, and then omega equals 2 pi f is the other. So I hope you understand the basis of this, and let's see how we can proceed with the calculations. So the period t is what they are asking. They have given that it goes through 2 complete cycles in 1 second. So that means frequency is 2 hertz, because 2 complete cycles means there are 2 oscillations per second. So per second means oscillations per second is hertz, so it is 2 hertz. So we can actually get the answer for B before we get the answer for part A. Then to get part A equation, you have to use the equation T equals 1 upon F. So you use that. T equals 1 upon F. T is what we are trying to find. 1 upon F is 2. Then you can get the answer. 1 upon 2 is obviously 0.5 or half a second. So I hope you understood that. Then the frequency obviously is 2 hertz because it happens in two complete cycles happen in 1 second, therefore it is 2 hertz. Then they are asking for the angular frequency. What is angular frequency equation? Omega equals 2 pi f. Omega equals 2 pi f. Then omega is what we are trying to find. We just found pi. We have to find the frequency. Frequency is 2. We found it in our earlier question. So we have 4 pi rads per second. Rads per second. That is our answer. I hope you understood. Then moving on to question number 2. Question number 12 rather. Figure 19.18 shows the displacement time graph for an oscillating mass. Use the graph to determine the following. So they have given some details and we have to use this particular graph. I'm sure you are looking at the book and I'm sure you have already done the question. So let's see how to do that. If you have any difficulties, let's try to figure it out. Amplitude, period, frequency, angular frequency, displacement at A, velocity at B and velocity at C. These are the stuff that they are asking from us. So before we get into a question, please remember, especially in A2, you have to read the questions properly and you have to understand what specifically they are asking, and you have to find out whether they have given any information. Now here we have to refer to the graph, but they might give you information in the question also. But here they have not given any other information, any additional information in the question. So we can directly get all the details from the graph itself. Right. The first thing is amplitude. Amplitude is the highest displacement. So that is this height, which is equal to 0.20 meters, and it is quite easy, right? 0.20 meters. Then they are asking for the period, right? So now we know that we have to find out how long it takes for one oscillation to occur. That means for this thing, there is a single oscillation. For single oscillation, it has taken 0.4 seconds, right? 0.4 seconds. Then we know the equation for frequency, right? T. Now we know that from this part, we can find out T. T is the time for one oscillation, period. We know the period. We know the equation that connects frequency and period. What is the equation? Equation is F equals 1 upon T. F equals 1 upon T. So we use that equation to find out F equals 1 upon T. F is what we are trying to find out. T is 0.4. When you resolve this, you will get 1 divided by 0.4 is 2.5. And what are the units? Hertz. Hertz would be the units. So your answer is 2.5 Hertz. I hope you understood. If you have any questions, please raise them. Right. Then they are asking for angular frequency. Quite easy. What is the equation that we need to use? Omega equals 2 pi f. Right? It should come naturally from your mind. Omega equals 2 pi f. Now 2 pi we leave it as it is. F we found, f is 2.5. Right? 2.5 into 2 is 5. 5 pi rads per second. I will write it here for more clarity. 5 pi rads per second. I hope you understood. Right. Then they are asking for displacement at A. Displacement at A. Where is A? A is this point. So displacement is, this. Okay. So then you extend it to the displacement, line, that is the y-axis. You get the answer to be minus 0.10 meters. That is the displacement at E. Right. Then they are asking in E, this in F, velocity at B. What is the point? This point. Because this is a displacement time graph. In a displacement time graph, the tangent would give you the velocity. So the velocity at this point is actually, because it is a parallel line to y-axis, to x-axis rather, it is going to be 0 meters per second. 0 meters per second is the answer for part F. I hope you understood. G, velocity at C. Velocity at C. So where is C first of all? C is this point. C is this point. And then you draw the tangent. You draw the tangent. You draw the tangent, make it a triangle, then find its relevant, the x and y length. That is, you will have to extend it up to, the y, to find the y-axis. You extend this to this, and then to get the x values, you extend it up to here and then find the ratio and you will get your answer. I'm pretty sure you must have got your answer. It would be 3.1 meters per second. So the gradient at C would be 3.1 meters per second. If you have any questions, please raise them.